Today my presentation is enhancement of photocatalyst for the reduction of chromium 6 plus by titanium dioxide decorate RGO nanocomposite. Outline of my talk is consists of 4 parts: introduction, experimental detail, result, and discussion. Finally is a conclusion. So nowadays we also know that the water pollution by organic pollutant is an ever increased problem in a global concern. When pollutants such as industrial waste from agricultural production, and also surrounding area contribute to increase the environmental more than durable. So we can see the pollutant in the Sano River in Italy, Yellow River in China, Yering River in India, and also in Thailand also have this problem is at the Chao Phraya River. So this problem is come from where? Actually, the water pollutant which arrive from model industrial and from rapid increase in urbanization of the human population. That means when the people increase, we can get more the pollutant, not only in water and it's also in air. So in case in the water, we can in this our work, we will see the chromium 6 plus. And the technique that we use or many people have been studied will be photocatalyst. That means the photocatalyst began to use for treatment of wastewater. This is because it's cheap. And we also know that commercial technology for wastewater treatment also use the biological oxidation, but it still cannot remove biorecordant compound. Another is a chemical oxidation. This one is can extend treatment times and unprecedented. For the physical filtration, but this one is quite costly because we need the pumping and physical filtration need to replace the filter. That means we have to order filter to replace many times. So can be costly. And finally, ultraviolet disinfection. But for this technique is a expensive part. So why many researchers or others focus on photocatalysts? This is because the oxidation is atmospheric oxygen. No consumption of expensive oxidizing chemical, and also no production of sludge. The photocatalyst reaction may be driven by sunlight, able to minimize of majority of organic pollutant, and also able to remove emerging contaminant and bacteria. This is because photocatalyst is also cheap method. We can use the sunlight to do the dye degradation. So why people use photocatalyst? This is because photocatalysis is an advanced oxidation process that is an environmentally friendly option and also one of the most critical technology in green chemistry today. And photocatalyst also using semiconductor nanomaterial and reduce graphene oxide that is suitable as a catalyst. So we know the structure of reduced graphene oxide later. Then the application of photocatalysis is an advantage in air purification, water Sorry, can you hear me?
Yes, ma'am. Ma'am, your slides are not moving, ma'am.
Oh, slide doesn't moving.
Yes, ma'am.
Mm. Eh, for me,
Ma'am, can you make it as a presentation mode?
yes. Can you?
Yes, thank you.
The slide is moving, right? Slide already moving, right? Now it's okay.
Yes, ma'am. You can proceed, ma'am.
Okay. Then, as we know, the photocatalyst is using semiconductor nanomaterial and reduce graphene oxide because that is suitable as a catalyst. And the application for photocatalysis is used in air purification, water disinfection, and also purification. So actually, we know that there are many semiconductor photocatalysis, such as nickel oxide, tin oxide, manganese oxide. My slide is not moving again. Uh, okay. So we can use semiconductor as a photocatalyst. Is a tin oxide, nickel oxide, uh, manganese oxide, zinc oxide, iron oxide, and also titanium dioxide. I don't know what's wrong with this one. Okay, maybe I give a talk like this. So, and then for in this work, titanium dioxide has been chosen to study as a semiconductor photocatalysis. This is because titanium dioxide is the most used as a catalyst because titanium dioxide has a 380 nanometer in wavelengths that is active under UV radiation. And titanium dioxide also has a good advantage is high chemical stability, low cost, non-toxicity, and environmental friendly. So in this work, we use titanium dioxide nanoparticle to decorate on reduced graphene oxide. And you also know that graphene is a one atom thick layer of carbon atom. And the property of graphene is a high electrical conductivity, large specific surface area, high mechanical strength, high chemical stability, and high mobility of charge carrier. Moreover, graphene also used as the photocatalyst properties. This is because metal oxide was hybridized with graphene can use as the semiconductor photocatalysis. So now let's come to from as we know graphene, then we can see the how can we get the reduced graphene oxide. For the reduced graphene oxide, actually, it starts from graphite. From the graphite, we can do the oxidation to get the graphene oxide. For the graphene oxide, it has a lot of functional group. So we have to reduce the functional group to be reduced graphene oxide. That means we do the reduction to remove the functional group, then become reduced graphene oxide. The purpose of reduced graphene oxide, this is because it has high absorption ability of organic material in an aqueous medium. Promote as visible light active semiconductor photocatalyst. Surface modification of RGO with any metal. And you can see from this picture, between RGO and semiconductor, we found that RGO has a narrow band gap. For the semiconductor, the band gap is a little bit wider. So that's why many people use the semiconductor or use metal decorate on reduced graphene oxide. And reduced graphene oxide can be the conductor too. Let's come to experimental method. In this class, we will start to synthesize graphene oxide by using hammer method. Firstly, we start from graphite and put in graphite in potassium permanganate, sodium nitrate, and stir for 15 minutes under temperature 5 degrees C and stir for 60 minutes. Then after that, we continue stir at room temperature for 5 days. Continue by adding DI water and stir. Continue to stir for 30 minutes. Finally, we also keep stirring at 90 degrees C temperature and stir for 60 minutes. After that, we add H2 hydrogen peroxide in the solution. After that, we get the powder, the solution into the centrifuge, wash with DI water and put in the hydrochloric solution. After that, dry in oven 60 degrees C for 16 hours. Finally, we can get the GO sheet. So after we get the GO graphene oxide, GO is mean graphene oxide. We also synthesis with titanium dioxide by decorate with the RGO. Then we start from GO and then put in the ethanol